In this module, we will learn the inputs, tools and techniques, and outputs of the Perform Quantitative Risk Analysis process. Perform Quantitative Risk Analysis is the process of using the updates to the risk register from Qualitative Risk Analysis to assign a cost or time value to each risk. It is important to understand the difference between qualitative risk analysis and quantitative risk analysis. Quantitative analysis focuses on valuating or measuring risk in dollars or sometimes in days. Remember that the purpose of this process is to predict the value of events which we have deemed to be uncertain. Since the occurrence and/or impacts of each risk are unknown, it is impossible to calculate the exact value the risk currently presents the project. We must rely on historical data, estimating from subject matter experts, modeling techniques, and other calculations to attempt to predict the value of each risk. Before we investigate the tools and techniques for performing quantitative risk analysis, it may be useful to think of some everyday risk models we encounter in our day-to-day lives. When turning on the local morning news, we hear meteorologists attempt to predict the weekly weather. While not always right, they create their best guess by looking at current environmental information, historical data, and models to predict likely outcomes. These models can forecast the probability and amount of rainfall or snowfall, or the most likely trajectory of a hurricane. Automotive insurance companies create models to predict the risk level of its customers. By asking you your age, driving history, credit score, address, and type of vehicle, they can calculate a competitive premium rate that minimizes their risk. Finally, if you've ever purchased a lottery ticket or dropped a quarter in a slot machine, you are trying to defy the model that has been created by odds makers in the gambling industry. While we subconsciously know that in the long run we are losing money when gambling, the opportunity of becoming an instant millionaire can be quite tempting. Key inputs to the Perform Quantitative Risk Analysis include management plans and the risk register. The scope, schedule, and cost baselines may provide some indication as to the overall percentage of budget and schedule that should be allocated to risk response or contingency. Quantitative analysis will require more objective data than qualitative analysis, which can be costly and time-consuming to obtain. Therefore, it is important to define where the project team should focus their efforts. The risk management plan should define which project objectives are the most important to protect and the thresholds for when quantitative analysis should be performed, such as only the top 5 or anything that has a medium or higher priority. The risk management plan will also define which tools and techniques should be used for this process. Since the probabilities and predicted impacts of each risk are subject to change and new risks may be identified throughout the project lifecycle, it is important to revisit this process. The risk management plan should describe how to iterate this process throughout the project lifecycle. The project risk register represents the key input since the team will need to understand the identified risks to be able to measure each of them. Since qualitative risk analysis is typically performed prior to this process, they should already be prioritized and contain information regarding the team's subjective understanding of probability and impact. Two additional inputs include enterprise environmental factors and organizational process assets. Enterprise environmental factors may include government standards, stakeholder culture, and the organization's existing infrastructure and tools. Understanding the project environment will be especially important throughout the risk management processes. Organizational process assets may contribute templates and lessons learned. The tools and techniques of the Perform Quantitative Risk Analysis process are organized into two major categories: data gathering representation techniques and analysis and modeling techniques. Simply put, this means we will need to conduct research about the uncertainties in our project environment and then try to model the possible outcomes that may exist. Data gathering on risk will typically require looking at historical data or interviewing experts in the field. These subject matter experts may be members of the project team or external to the organization. One popular way to represent the data is through probability distributions. This is similar to the data we used when learning PERT. Estimates may be provided for pessimistic, most likely, and optimistic outcomes, and statistical probability can be used to generate the value of risk. Common representations include triangular, normal, log normal, beta, uniform, or discrete distribution. Once data is collected, there are various analysis and modeling techniques which may be used. Two common methods include expected monetary value and decision trees, which can attempt to evaluate risk in dollars or sometimes in days. We will take a closer look at these in the following slides. Sensitivity analysis can be used to determine which project risks have the largest potential impact to project objectives. The results can be displayed using a tornado diagram, which shows the relative variance levels among a set of data. In advanced applications, simulation tools can be used, such as Monte Carlo analysis, a computer model that can show various project schedule outcomes based on the potential variances of estimated durations and network logic. Expected monetary value is a technique that can be used to attempt to calculate the current value that an uncertain event or condition brings to the project. Let's consider a brief example. After purchasing a new appliance for $1,000, the store manager asks if you would like to add a 3-year extended warranty for $100. In order to make this decision, it would be useful to have some more information about the life expectancy of the product and cost of repair or replacement. Using your best judgment, you guess that there is a 15% chance that the product will have an issue during the covered period, and that the average repair or replacement fee would be $500. With this information, we can make a more educated guess at how to handle the situation by finding the expected monetary value of the risk of failure. The formula for expected monetary value is simply the probability of occurrence multiplied by the impact on project objectives. In this example, the probability of a failure is 15%, and the average impact is negative $500. In project risk management, it is important to always treat threats as negative impacts and opportunities as positive impacts. Using this formula, we can calculate the expected monetary value as negative $75. This simple model has estimated the value of the risk is negative $75 as compared to the cost of the warranty, which is $100. So do you buy the insurance? If you were to base your decisions on numbers alone, as you should on the exam, then you should not buy the warranty. The real answer may depend on your risk tolerance. Those that are risk tolerant will likely not buy the warranty, while those that are risk averse may be willing to buy the warranty to help them sleep better at night. Expected monetary value alone is great to estimate the value of a single risk event by itself. But in many cases, a single decision may result in multiple uncertainties, each with a unique probability and impact. To model these more complex scenarios, decision trees can be used to aggregate the individual expected monetary value for a series of events to understand the overall expected monetary value for an entire decision. Since you may be required to use decision trees on the PMP exam, we will learn the math behind them in a separate module. After completing the Identify Risk process, the risk register may just be a simple list of risks, potential triggers, and risk owners. As a result of qualitative analysis, it will include the relative priorities of each risk, such as high, medium, or low. As a result of quantitative analysis, risks may be quantified using time and cost values, such as expected monetary value. Project document updates are made to the risk report to include an assessment of overall project risk exposure, a detailed analysis of risk value through S-curves, tornado diagrams, and/or criticality analysis, along with a narrative interpretation of results. Further, the risk register may be revised to include a probabilistic estimate of achieving baseline values, a reprioritization, and insights to any trends that have been observed. Perform quantitative risk analysis is the process of using the updates to the risk register from qualitative risk analysis to assign cost or time values to each risk. It is important to understand the difference between qualitative risk analysis and quantitative risk analysis. Quantitative analysis focuses on valuating or measuring risk in dollars or sometimes in days.